Do you know Swift, Objective-C, and Java? Can you use them in tools like Xcode or Android Studio? If so, awesome. But for everyone else, there's NativeScript. It's a cross-platform framework for building native iOS and Android apps using skills you already have: JavaScript or TypeScript, CSS, and a XAML-like XML markup. Start building your dream native mobile apps today. Use the NativeScript command line interface for free, or use NativeScript in Visual Studio with a Telerik platform subscription, which will enable you to build iOS apps without the glowing apple. Get started for free at telerik.com/nativescript.
From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 509. In this episode, Scott talks with Ben Adams about the MMO game Age of Ascent.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. Today I'm talking with Ben Adams. He's the CTO at Illyriad Games, and they're working on an upcoming video game called Age of Ascent. Thanks for chatting with me.
Hi, Scott. Thanks for inviting me.
So your game has been being worked on now for a while. It's coming up on 2 years since you started your public alpha.
Yeah, it has. It's quite an exciting journey it's been. There's been all sorts of challenges along the way. So
you were trying to break scalability records, though, in the Guinness Book of World Records, 2 years ago. Why did you start with scale at top of mind?
Well, games in almost the last 2 decades haven't really changed. I mean, they've become more beautiful. The physics has become better. But in terms of, the concurrency, the number of players that play together, it hasn't really changed. I mean, now the big improvements are, say, in a big AAA title, you go from 32 players in a match to 64. But, 10 years ago, from the amount technology has moved on since then, that's not really a great advancement. So we're trying to usher in sort of ultra MMO, kind of an entirely new scale of gaming to harness the power of the cloud and, just be able to dynamically scale. And I mean, that's what it's all about.
So yeah, when I play Battlefront, I might get 32 players. I've seen 64-player games, and that's considered to be extraordinary. But didn't a game called Eve Online get 3,000 or 4,000 players going a couple years back?
Well, that was the record we were trying to beat.
I see. So 4,000 is the record of concurrent players in one world.
Well, yeah, 4,000 is the record for players in a single battle. However, I mean, I don't want to call out Eve, but they in order to achieve that, they do slow the speed of gameplay down by to 10% speed. Whereas we're looking at sort of a real time, keeping it Twitch based and really fast. And there are people looking at that. So there's like PlanetSide 2, I think, and there was a Man versus Machine, which was a sort of tech preview where they did 1,000 players. So that was sort of the low bar we were trying to get over. For our Guinness World Record attempt, on the day we only had about 996 players turn up, which was unfortunate because we just missed that low bar by about 5 players.
But the game, though, you've designed it with an order of magnitude more scale, right? I mean, you could potentially have tens of thousands of players in a single battle if you wanted, could you not?
Absolutely. I mean, we've tested it about a year ago. We tested it up to 50,000 players in a single battle, where and this is why performance is so important to us, where we were doing 297 million application messages a second, in order to have all these players talking to each other.
I've heard articles, and you'll have to forgive my ignorance, because when I worked on applications of massive scale, we were more like banking applications, and we topped out at, a few tens of thousands of people, but they weren't sending dozens of messages a second. They were checking their online banking balances. So I realized that gaming is a very different experience. But when I think about large-scale message passing in the millions or billions, I usually hear people talk about WhatsApp and Erlang, and Tim Bray, kind of like most famously said somewhere around 2008 that if he were going to build a large-scale message passing system, he would do it in Erlang, and then WhatsApp went and did it. Did you look at languages like that or systems like that for something of this scale?
We did, but our expertise is the .NET variety of languages and C#. So that's where we focused, and we've spent many years with it and know where to optimize it, where all the rough edges are, and how to do perf analysis and work out where we need to improve things.
Was there any concern? I mean, I hear .NET can't scale, and people point to Stack Overflow as the example, but it's fair to say that there's not a huge amount of startups out there doing .NET. And while in gaming, though, there is quite a few people using .NET, but they use it because Unity brings them into the world of C#.
I don't think we had any worries. I mean, where our previous title, the eponymous Illyriad, is an ASP.NET application based on MVC, and that is entirely C#. So, and that is also a massively multiplayer game. It's a lot more slow paced than what we're doing here, which is Twitch combat. But in terms of the performance and the level of concurrency that we were able to achieve, we had no worries whatsoever. I mean, the whole landscape has changed quite a bit from when async started coming in. That's where it really started to change how things worked.
So let's talk a little bit about how you scale and how the back end works before we get into the front end, which is itself interesting enough to have almost its own show, because the technology behind this is really fascinating. But suffice it to say, right now, if you want to be involved in the beta test or the alpha test, this is done in the browser, right? This is all HTML5, WebGL, web workers. Is that correct?
Yep.
So if I were to go in F12 tools and watch the messages across the wire, what are we talking here?
It's entirely HTTPS WebSockets. We have to go over HTTPS because WebSockets don't work well for everybody over the open web, because not every intermediary, although all the browsers understand it, the intermediaries, proxies and routers don't. Some of them interfere with the communication and will break it. So that's why it's all over HTTPS. But it is essentially WebSockets between us and the browser.
Does that additional layer there itself bring in scalability issues and introduce quite a bit of latency?
That was somewhere where we had a worry. Probably of anything, the fact we had to go over HTTPS was our biggest worry. But no, we've had no problems, and it works.
Interesting. Couldn't you have just been more draconian in your technical requirements and just said, well, it's going to be WebSockets proper, and we're not going to, and if you can't do it, you can't play?
Well, no, I mean, one of our sort of tenets is, it's open web, it's available to anyone, and you can just come along and you're instantly in the game. I mean, we do have a minimum bar, which is that you need to be able to run WebGL, although that's for the main flying in space combat, but we will still have non-WebGL things. So if you want to trade in your market and organize your ship loadout and all that sort of stuff, you'll still be able to do that, and that's more of a traditional web page.
Okay, so you're talking WebSockets over SSL. And what is listening on the other side? Are we using a cloud-based servers? Are they stateful, stateless? What's on the back end?
On the back end, we have a Kestrel server listening in Service Fabric on Azure. And that enables us to scale out dynamically, and also scale back in dynamically. So if we have thousands of players, two alliances go to war, and they all decide to meet in the same place, we might be running on a tiny cluster. And at that point, as the messages increase and the CPU load increases, we essentially unfold space and spread it over more and more machines, so it becomes bigger. And that's sort of a seamless transition. The Service Fabric gives us that sort of reliable front-end architecture that's always available as we're unfolding space, and it organizes the orchestration behind it. And then, when the combat's died down, we fold space back in, and it's based on sort of player density. Was
Service Fabric like the thing that you needed? Because I've heard lots of things about it, but it still has a certain amount of, for lack of a better way of phrasing it, it smells like PhDs when I start thinking about Azure Service Fabric, and I go, I don't know if I'm smart enough to use that.
Initially we were building our own system, and Service Fabric sort of came along at the right time. It was, we had a look at Orleans previously, which was another actor-based. Well, we're not using actors in Service Fabric. We're using these stateful and stateless services, and tried to see if that would meet our needs, and it didn't quite fit what we were trying to do. So we started building our own system that would do this orchestration of space unfolding and dynamically repartitioning players. And then it sort of came along at the right time, where we weren't too far down the path, and it solved an awful lot more problems. And there is a whiff of PhD in terms of how the problems have been solved, but it's in terms of using it, it's not that hard.
I've seen demos where Service Fabric will make millions of objects, and you, as the person managing state, just doesn't have to think about it. You just make a million of these things, and you let Service Fabric figure it out. Is that basically how it works? Is it that simple, or are you thinking about how to scale as you're coding this?
Well, they have two different scenarios. So that's the actor model, where you have all these individual items that, as you say, live. You can create millions of them, and it deals with the orchestration. We use the other one, which is the microservice based thing, where we have sort of concurrent, persistent, reliable collections that we store state in. And it's pretty much like .NET collections, dictionaries and so forth. And then it handles, it looks at the CPU loads and works out where to move things about. And you can put constraints on. So you might say, this type of service should never occupy the same server as this type of server, because that the contention will be bad between them. Or you want them on particular size VMs. But yeah, it organizes where it needs to move things around. And if, you have the primary fall over, then you have secondaries that immediately step in and take over for a sort of seamless reliability.
I've always felt that when someone does a startup or they sit down and they want to make something amazing, the fact that often we hear that, before I make this cool space shooting game, I have to design a microservice framework that will manage state. You know what I mean? It's like, before I do this amazing high-level thing that's not been done before, I need to go and do this crazy low-level thing that hasn't been done before. And it just seems so, against the way business should be done, Are you consciously trying to use available services and open source and projects that have reliably solved things before? Or are you finding yourself dropping down into the low level a lot and kind of going, gosh, why am I thinking about, byte buffers at this level? I really need to be making space games.
Yeah, we are dropping down to quite low level, but I mean, it is because we are trying to do it at such a huge scale. So we have, about every 2 months we'll have a meeting discussing our message packets, and a single bit, not a byte, a single bit in our message explodes to 900 megabytes a second. Sorry, not 900, 9 megabytes a second in server bandwidth at that kind of scale. So we do need to go down to that level. However, if there is a technology that exists, we do try and use it. So, for instance, Service Fabric, Kestrel, ASP.NET, and Core CLR.
Mm-hmm. Are you familiar with Captain Proto or protocol buffers? Do you use those at all?
No, I am familiar with them, but we do have very custom messages to. Mm-hmm. So it's very domain specific in terms of what in a message we can discard, what we can make slightly lossy, and all that sort of stuff. And when we can send it, maybe we can put an extra header in one message, and then all the others don't need it.
I see.
Sort of reduced data.
So it really is a completely custom binary protocol. It's not just taking structs and serializing them across the wire. It is down, like you said, to the byte.
To the bit.
To the bit, pardon me. That's amazing. I mean, that's insane. An extra bit is an extra gig on the wire, when you run into scale. But it makes sense, right? That is the issue. There's the old joke that I always like to tell about scalability is that if you do nothing, you can do it infinitely.
Indeed, I have a tweet from you on one of our blog posts that says that.
So
doing nothing can scale infinitely.
So speaking of doing nothing infinitely, you have most recently become the primary committer on the ASP.NET Kestrel web server. This is the libuv-based web server that Microsoft is going to ship with ASP.NET 5. And about 3 weeks ago, you did a merge with ASP.NET Kestrel, and you went from 88 bytes allocated per request to 0. How do you do that, and what is the significance of something like that?
Well, with the very high throughput, obviously you're doing lots and lots and lots of requests per second. Even though in the .NET world, you don't have to so much worry about your memory because it's garbage collected. You don't need to know when you're allocating, deallocating, and so forth. You are putting load on the garbage collector in order for it to do that work. So the idea is if you don't need to allocate the memory and you can avoid it, then the garbage collector doesn't have to do the cleanup work, which gives more back to the application, so you can do even more work.
Which is do nothing in this case.
Exactly.
Like if you can reuse something, don't do it. And we abuse, and honestly, for the last 10 years, even 20 years, we've abused garbage collectors. But we always have to pay for it when things pause, when the actual garbage collection occurs.
Completely. I mean, when I was testing the throughput, I don't know, it was about 6 months ago. If you're putting a very heavy load through it, it would perform quite well. But then after, about 5 minutes of doing 500,000 requests a second, suddenly everything would stop. All the network traffic would drop to 0. Your CPU would still be on 100% as the garbage collector was going through the gigabytes and gigabytes and gigabytes that you've been allocating per second.
This episode of Hansel Minutes is brought to you by Braintree, code for easy online payments. If you're building a mobile app and you're searching for a simple payment solution, check out Braintree. The Braintree V.0 SDK makes it easy to offer multiple mobile payment types, so you can start accepting PayPal, Apple Pay, Bitcoin, Venmo, credit cards, and more, all with a single integration. One small snippet of code, and you're set up in less than 10 minutes. If you don't have time, you can give them a call. They'll even handle the integration for you and walk you through it. The SDK supports 7 languages: .NET, Node, Java, Perl, PHP, Python, and Ruby, elegant code, clear documentation. To learn more and for your first $50,000 in transactions fee-free, go to braintreepayments.com/Hanselman. That's braintreepayments.com/Hanselman. The decision to go Kestrel and to go ASP.NET 5, you're doing something that's pretty alpha. It's pretty on the cutting edge, the bleeding edge. Again, no concerns about racing forward into the future using WebGL and the latest JavaScript things and the latest everything on both on the server and on the client. Have you gotten in trouble? Have you gotten nailed?
Well, originally we weren't going that direction. I mean, previously we were at ASP.NET. I suppose it's 4, was it? The version before? 4.6, yeah. And it didn't quite work for us for what we were trying to do for Age of Ascent. We did move to Katana rather than as our first step, and then we did run into some issues. There were some issues that we found with the framework that we fed back to the team and got fixed with WebSockets. Mm-hmm. And then to get even more performance, we moved to HTTP listener, so we dropped IIS. So we were going sort of raw to the socket, and then we found we needed even more. And so at which point we started developing our own web server to serve that need. And I think around that time, ASP.NET 5 was always open source, I think. Mm-hmm. But around that time, a whole bunch of interesting things started happening. So .NET open sourced the whole framework. Then .NET Core appeared, and that was suddenly pay for play. That was a lot more what we wanted. And then I started paying a lot more attention to what was happening in the ASP.NET world with ASP.NET 5. It sort of woke me up a little bit. Mm-hmm. And I thought maybe time to revisit. Mm-hmm. And I think I was watching a community stand-up, and Damien was saying that you created a benchmarks repo. Mm-hmm. So, and he's accepting pull requests of different servers to see what was going on, and they were showing their results. And so I gave a sort of a view of the server we were creating, which was the using the registered IO extensions in Windows, and I pushed that to the benchmarks, and he seemed quite happy with it. But there's an awful lot more than what we were trying to do specifically for flying in space, which is where we need that really high throughput. We wanted web services of web pages, assets, web API, all that sort of stuff, which is something extra that ASP.NET 5 gives you, rather than we have a raw WebSocket server. Mm-hmm. So we started looking at whether we could put ASP.NET 5 on top of our web server. Mm. And so I was talking to Damien Edwards and David Fowler about that, and they were helping me sort of what I needed to put in the web server to make it work. And then at one point, David Fowler asked, have you ever thought of maybe improving Kestrel to work with what you want to do? And I thought, yeah, why not? So so at that point I started looking at all the performance metrics of Kestrel, and that's where it all started. Yeah. And began. And although I put pull requests in that make it an awful lot faster, it's come with all sorts of extra benefits. So I have a team of people at Microsoft who are looking at all my changes and going, well, have you thought of doing this? Have you thought of doing that? And suddenly all my improvements become an awful lot better. And there are, other fringe benefits. I get an enterprise support agreement for my own code. I mean, that's not too bad.
So that's a really interesting idea, right? If you work on code that we, Microsoft, are going to eventually ship, then it turns around and we hand it right back to you with full support because it's the real thing. Which gets to the original kind of question about 15, 20 minutes ago, where it's like, we're making a space game. Do we need to have our own web server that we wrote from scratch?
And no, it turns out that way.
It turns out that you don't.
I mean, originally it was, but we have sort of shaped Kestrel to meet our needs, which is also works with the needs of the community
selfishly,
and everybody else.
but everyone wins, right? I mean, that's kind of how it's supposed to work, right? You needed a feature, and it just happened to be features that other people needed as well, and everybody wins. Hopefully, it won't get to a point where you have to fork it, but it sounds like everyone wins so far. Yeah,
definitely. I mean, open source it's like a force multiplier. So everything it sort of gives us the best of both worlds. We've got like a great diversity of minds from all around the world, sort of giving a wider viewpoint because obviously we have quite a narrow focus. And they're all specialists, and we can contribute if we need fixes, and the community improves on what we do and our contributions, and everything just improves exponentially beyond it.
Right. So let's move to the client in the last remaining minutes here. Right now, it's in the browser, right? So when we talk about cross-platform things, we kind of think about the browser and say, well, if it runs in the browser, it runs on every platform. But you're so JavaScript heavy and so WebGL heavy. Are the platforms that you're targeting Chrome and Chromium and then Microsoft Edge? Like, are those the quote-unquote operating systems that are your targets?
Yes. I mean, we go a little bit further than just the browser. I mean, we are essentially just the browser, but different environments, people like apps and things they can install also. So if we're looking at Steam, then we'll need an exe. If we're looking at the Windows Store, we need an app that we can put in there. But in the Windows Store, we're HTML, JS app that we put in the store, and on for Steam, or if people just want to download an exe and install some random thing from the internet, we use the Electron, the Atom shell, and which is Chromium, and that's how we present it. So we have the website, we have the Edge-based Windows 10 universal platform. That works across devices, and then we have the Electron shell as well.
Electron, formerly Atom shell. Historically though, historically like right now, there seems to be some negativity, I would say, from not the end users. I don't think that the non-technical care, but the just technical enough to be dangerous. Look on Electron applications and Atom shell applications with disdain, probably inappropriate disdain, but they'll look at something like the Slack Windows application and they'll install it and they go, this is just the web browser in a shell. It's certainly not. They don't realize how complicated what they're doing is going on there. But how do you think we combat that? Like, do you combat it with just amazing graphics and a great gaming experience? And hey, I downloaded it from Steam, so it doesn't really matter?
I mean, one of the issues that we had with Illyriad was because it was a game in a web browser. Sort of game reviewers they're like, well, that's not a game. Magazines don't understand it. It's
just prejudice.
Yeah. So I mean, it is moving to it won't seem like just a website in an app. I mean, that's what it will be. So we'll probably not concentrate on it. I mean, the end user is just the experience that's important, really.
Well, frankly, if I go into Steam and I buy the thing and it looks like an official game and it installs and it shows up on my machine and I go full screen and it is doing 60 frames a second and it looks great, I don't think I'm going to care.
But there are some extra benefits that we have with, say, the Universal Windows platform and with the Electron shell, in that we can also, our build process, we have, it goes through, we put the assets for the website, we throw in some pre-gzipping for the website so we can download it. But we also deploy the assets into those applications, so they're running with local assets. So, it's also a little bit bigger. People.
So the Universal Windows app, I'll be able to go in the store. Like, you'll be in as many stores as you can be in, I assume. You want everyone to play your game. So I go into the Steam store and you'll be there. It'll come down and it'll look and run exactly as it should. If I go into the Universal Windows store, it'll look and run as it should. It's the same code though, right? It's JavaScript and WebGL, isn't it?
It's exactly the same in all. I mean, there are two slight differences with the Windows Universal Platform and Electron, in that they're actually better than the web version, because they have, both of them have, we essentially can put an iframe in them that we put the WebGL in. And on Atom Shell, that's a web view, and I think we translate that into a web view. And in the Universal Windows platform, we translate it into, I think it's an XMS web view. And that then runs in a separate thread. So we have two rendering threads. So we can put the UI on top of the WebGL so they don't actually interfere with each other.
And the result is a better experience.
Yeah. So we can have like an animated UI and it's not interfering with the WebGL. But that's just a fringe benefit. We're great on the web, so...
And you don't spend lots of time, chasing incompatibilities. It seems like I hear so often when I talk to like enterprise developers or people building text boxes over data, at a healthcare company or an insurance company. They're like, oh, we struggle with, browser incompatibilities, and I just can't write JavaScript that will validate this text box. But you somehow have made a space game that runs everywhere.
Yeah, I do find it strange. I mean, there's even people that have a trouble. I can't even scroll my page
without it being janky.
Yeah, and it's like, well, that was a problem that was solved 20 years ago. But we pay an enormous amount of detail to what's going on in the JavaScript, if there are any errors. Because if we're writing console errors hidden behind the scenes, you've got to call up F12 and you just see the site spewing thousands and thousands of errors. That's hitting our frame rate directly, and suddenly the game looks rubbish. So it's that we pay a lot of attention to it. We have to pay a lot of attention to it, but I'm not sure everybody looks at the detail as much as maybe they should.
You're being very kind, and I don't want to call you out for being excessively English or anything, but are you basically saying that people just need to try a little harder? Pay a little more attention?
So. I mean, it's not, because we're amazingly brilliant, although, it probably is, but to make up for my Britishness.
There you go. Excellent.
But the people just need to look a little bit deeper, pay attention to the details. It's more, look at what's going on, pay attention to what's going on in your app. That's what's really important. You
think it's fair to say that a lot of people treat these systems as black boxes, and they just don't really know what's going on? Like I always use the example of jQuery, where it's like, I use jQuery, and then a miracle occurs, and the JavaScript runs, but they don't really understand what's going on as deep enough, maybe enough layers of abstraction down.
I don't think so. I mean, I used to be the greatest fan of jQuery, but browsers have moved on. JavaScript does it all natively now. Not everything.
Sure.
There's polyfills, and jQuery does help with a lot of things. But, you go to Stack Overflow and I'm trying to do this in JavaScript, and, the the first 10 ounces start with a dollar sign. Here's the jQuery you need to write. And it's like, no, you can use the JavaScript for this. It's really simple. Or, you're doing an animation, you're doing like a jQuery animation. And it's like, well, you can do that in CSS. And, it's hardware accelerated by the browser. You don't need to be updating, moving top left of, a text box every frame.
Seems like the troubles of the last 10 years of browser compatibility perhaps have poisoned us, and we're still doing stuff the way it was done years ago, and it's just not necessary anymore.
Completely. I mean, if we're using the patterns that we used to use, probably about 10, even 5 years ago, that will actually make your website performance worse. Everything has changed. The browsers have caught up. I mean, if you need to support, say, IE6, which hopefully nobody does now, but there are situations. But if you also work with the modern browsers, then if everybody does it, then we can release our grip on the old browsers, and a lot of these compatibility issues go away. And all the browser vendors are working really hard to make sure there aren't these issues.
That's a good point. The fact that we all want this to happen, I think we shouldn't underestimate the power of the collective. So when can people play Age of Ascent, and where and what platforms?
Well, we're currently available on the web, and we have a monthly playtest. We're gearing that up to be more frequent, and we're hoping around March, April that we will move into a sort of 24-hour continuous game. So that will be like our first public continuous alpha of the massively multiplayer game. But we're going to be on all platforms. The Universal Windows platform, Mac, PC, Windows Store. We'll be on your phone. I mean, one of the things we have is we're also doing. I didn't mention this. Build your own cockpit, where I have all these devices. I have a tablet. I have a phone. I have. I want to bring them in and build my own cockpit. I want my radar on my Surface. I want my target list on my phone. You've got all these devices. They've all got browsers. We're gonna bring them in. You can create your own little bridge, as it were, if you wanted to.
Very cool. It seems like the massively multiplayer space game, this is the year for that experience.
It does seem to be.
And suddenly the pressure's on you now to have VR enabled Age of Ascent. So we're going to want that as well when we start playing your game.
Well, there are movements for VR in the browser, but it might be early days for us.
Very cool. Thanks, Ben Adams, so much for chatting with me today.
Thank you very much for having me.
This has been another episode of Hansel Minutes, and we'll see you again next week.